Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give another example related to hypothesis testing for the difference in the population means. And here is an example of having dependent samples. So here we have a dietitian that wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. The subjects were pre-tested, so here are the results. And then they took the mineral for a 6-week period, and after that the subjects are again tested. So these are the results here. Can it be concluded that the cholesterol level has been changed? So cholesterol level is changed at alpha equals to 0.1. Assume the distribution of PET differences is normally distributed. Right, so here if you look at this statement given here, cholesterol level has been changed. So basically you're looking at whether mu b, the mean of the cholesterol level before, it is not similar, because if it is changed, therefore the cholesterol level is not going to be similar to the mean of cholesterol level after the diet is supplemented by a certain mineral. So this is corresponding to the alternative statement. So this sentence here corresponds to the alternative statement. So if we start off with the first step of writing the hypothesis, it will be H1 mu b before it's not equal to mu a. The fact that it is changed means it's not going to be equal, and therefore we know that the null hypothesis is going to be mu before is equal to mu after. And again, I prefer to write it in terms of mu b minus mu a is equal to 0, and H1 is mu b minus mu a not equal to 0. And since this is the case of samples being dependent, therefore we're going to use a special notation, which is H null. We're going to represent this whole mu b minus mu a as mu d is equal to 0, and H1 mu d is not equal to 0. Okay, because we're just going to say that this is the case of the dependent samples. So D here is represents the new data set. So D here is the new data set, which is the differences of before and after. Alright, that's the first step. So the second step, before we can calculate the test statistic and so on, what you need to do is you need to find the difference between before and after. So if 210 minus 190, the difference is 20. This is the new data set. This one, the difference is 65. This is negative 2. This is 2, negative 1, and 16. So if you remember, this is actually the same example which you have seen in chapter 2, the interval estimation, when you have the case of dependent sample. So now, based on this new data set, you need to calculate, so based on this new data set here, you need to calculate the mean of this new data, and you'll be able to get that the mean is going to be 16.67. so that's the mean. I'm going to call it this is D bar, the mean of the new data set, which is represented by D. And then if you continue, if you can find the standard deviation of this data set. The standard deviation is about 25.3903. so that is the standard deviation for this new data set D. Okay, so here we have the first step. Now we're going to calculate the test statistic. The second step is to calculate the test statistic. And the test statistic, if you refer to the previous slide, the test statistic is going to be this one. Okay, so when you want to test the difference in the population means, and then you have samples that are dependent, so you need to find a new data set, which is before minus after or after minus before, and this is the test statistic that you will be using here, which indicates that you will refer to the t-distribution table later on in order to find either the p-value or the critical value. Okay, let's go back to our example. So now the test statistic is going to be t is equal to d bar minus mu d over, this one is the standard deviation for the new data set, square root n. Okay, and based on what I've said here, d bar is 16.67 and mu d is going to be equal to 0 based on the statement given here. So mu d is going to be 0 over standard deviation is 25.3903. Here is square root of n is 6, so there are 6 subjects altogether, and based on this you'll be able to get that the test statistic value is 1.61. Now the third step is to find out the critical regions and also the critical values. So this is the third step. This is the sketch of a t-distribution. The middle point here is at 0. And if you look at this alternative statement, it is a two-sided hypothesis where the direction can be either to the left or to the right. Therefore, we have two critical regions, and the area of each critical region is going to be 0.10 divided by 2, so it's going to be 0.05 each. Okay, so our job is to find what is the critical value at this point and this point. So the critical value is the value on the horizontal axis here. So if you refer to the t-distribution table, so if you refer to the t-distribution table here, we have the area which is 0.05. Similar, what we have over here is similar to the diagram given on the table, and therefore what we need to look up is alpha 0.05, which is this one. Now degrees of freedom is going to be 6 minus 1. 6 is the number of subjects minus 1, so degrees of freedom is equal to 5, and therefore the critical value is this one. On the positive side, the critical value is 2.015, and since this is symmetric, we know that if you have the same area of 0.05 on this side, the critical value for this is going to be negative 2.015. Okay, so if we go back to this example here, the critical value for this one is 2.015 and negative 2.015. Okay, I'm just going to write down and clarify the values. So critical value is plus minus 2.015. Now the fourth step is for you to decide whether you should reject or do not reject the null hypothesis. The fourth step is the decision process, and you will have to do it based on comparing the test statistic and the critical value that you have over here. So if you look at the value of test statistic 1.61, the value is going to be somewhere here. So this is 1.61, and clearly this value doesn't fall into the critical region. Okay, so I'm going to write down the test statistic 1.61 doesn't fall into the critical region. Okay, therefore H null cannot be rejected. Okay, and the last step is for you to come up with a conclusion. And as I said earlier, whenever you want to write the conclusion, you always relate with the alternative hypothesis here. And if you look at the statement given in the question, the alternative statement here is the same as this one, where it says cholesterol level has been changed. So you can use this sentence here in order to write down the conclusion. So I'm going to say that there is not enough evidence to support this statement here. And what is this statement? So there is not enough evidence to conclude that the cholesterol level has been changed at alpha equals to 0.05. Oh, sorry, at alpha equals to 0.10. Alright, I think that's all for now. Thank you very much for watching.